Hey everyone, my name's Anand Sanghani and I'm a SE with Itential. And I'm going to follow on and drill a little bit deeper into what Chris has just been talking about. I'm going to talk about our automation platform, run through some of the features and benefits. I'll talk about our automation gateway and show you, what we mean by leveraging what you have today. And then I'm going to run through a quick demo to really kind of drive home the benefits of the architecture that you've just seen. Okay, so before I go into the depths of everything, let's just go back a little bit, and I just want to convey, why we did things the way we did things. And these are four of our core principles. So these are things that we feel are critical to be successful. And we've applied these principles from the ground up. So when we built our platform, these were baked in. And as we continue to develop new products and new components, these are always top of mind. So at the first, we look at APIs, and for us, APIs are important. We talk about automation a lot, and when you look at building a solution and automating the solution, it's typically interacting with different APIs across different systems, and trying to invoke the capabilities that they offer. API first for us is being able to consume those fine-grained calls and consolidating those into our application and presenting them via an API to our consumers. So whether it's another client that's calling the API, whether it's our own user interfaces, from our perspective, everything has to be API first. So when we run through the demos in the next few minutes, every mouse click I make, every call I invoke is available to everybody who uses the platform through the APIs, and that's important. The next one is abstraction and federation, and we had some questions around the declarative nature of the systems that we have in place today. So having a principle of abstraction and federation really kind of helps us in making life easy from our application perspective. And the reason we've done this is, it's purely selfish. I mean, Chris mentioned, years ago, you'd have written your device drivers to talk to the device, and you'd have built your vertical application. And as things changed, you'd have to make the changes to that vertical silo. We didn't want to do that because we recognize that the landscape is ever changing. So there's always going to be new controllers and new orchestration systems in the mix. So we had to come up with a way that allowed us to be smart about how we write our applications. So being able to provide a layer of abstraction and really drive an intent-based paradigm helps us build these applications in an agnostic way. And with the abstraction, federation for us is also a second. It's a very important thing. I mean, federation. I'm sure a lot of people use the word federation, but for us, federation is all about making sure that we can get to the data from the systems that best have that data. So it's all about source of truth. It's all about making sure the data is accurate. And typically in the past, systems would consume that information, store it in their repositories, and then have to worry about whether it's stale. Given the speed at which we are kind of moving in the networking world, we can no longer afford to do that. So for us, federation is all about making sure we have real-time information from the systems that have this information. So federation is key. And then model consumption. We touched on it earlier. We have so many different vendors across so many different domains, creating a abstraction layer, creating models to really present their capabilities in this declarative way. We've got systems that talk Yang, that talk YAML, that talk Tosca, all providing a way of specifying what they can do. Now, for us to really build a end-to-end solution, we want to be able to consume these models. So we want to be able to discover them, we want to be able to consume them, and we want to make them available within our platforms to the people who are building the solutions. Otherwise, you've just got these silos that can be run independently, but you need to join these things together to give you a truly end-to-end solution. And the last aspect here is all about low code. And I'm sure whenever you talk to platform people, they say, yeah, we've got low code. Low code for us is slightly different. Yes, we want to make it very easy for people to use our platform. The reason we want to do that is, we see building automation solutions as an inclusive journey. So we want participation from as many people as possible. We've been involved in a number of different use cases across different customers where their environments are very siloed. The network engineering team don't get on with the operations teams. They don't get on with the security teams, or there's very little communication across the board. And for you to be truly successful in building a solution that spans these different teams, trying to get people involved in the same way really helps. And then giving them the tools to be able to do that, where they don't have to understand how to write Python or write, JavaScript or Java, it really helps them kind of embrace the technology and get the buy-in that you need to be successful. Okay, so let's drill a little bit deeper into that previous architecture slide you saw. So what I have here is, I want to try and show you some of the benefits of this layered architecture. And I'm going to use our configuration manager application to run through this example. And, I'll show you the demo in a second, but the configuration manager really is the entry point. And, when somebody clicks in there, let's have a look at what's happening behind the scenes. Now, Chris already mentioned about the adapter layer, and the boxes in orange at the bottom here, they're essentially our adapter layer and the adapters that we have here. On this picture, I've just given 3 examples. They're just picked out here to try and give you a simple demo that we can kind of drive the story home. On the right-hand side there, we have a Viptela adapter. We've got a Viptela controller running. And the Viptela APIs are, they return some JSON payloads. You invoke them over HTTP or HTTPS, and they present the information or their capabilities through that API. So the adapter talks to Viptela. In a similar way, we have the NSO adapter, which talks to Cisco's service orchestration platform. Similar principle. So that platform, manages devices, also does service orchestration, but it uses netconf yang. And so it uses a different technology, presents data in a different way. And so the NSO adapter's job is really to try and talk to that system and get the information from that system. The automation gateway on the left-hand side here. So that's our product that allows us to integrate with your current DevOps tools, your current scripts, things that you have running today that you want to leverage in your automation solutions. So in this example here, I've got it pointing to a Ansible installation, and I'm going to use Ansible to try and understand what devices that Ansible installation is managing. And again, so for those of you familiar with Ansible, I'm sure a lot of you have played with Ansible. YAML and Python is typically what you're going to be interacting with. So 3 different systems, 3 different ways of interacting with the systems, 3 different models. So these APIs, there's very little commonality in the data you get back. So what we do is, we get that information, we consolidate it, and we normalize it into a JSON schema. So, we think JSON is the payload that's typically used in a lot of systems, and JSON schema is a very important way of being able to model what that information looks like. So we can take these disparate systems and the disparate data and join it together. And our broker layer here is really where the magic happens now. So in the broker layer, you have the ability to define the intent that you want to be able to satisfy. For example here, I've just called out 4 simple things in our device broker. I want the device broker to be able to list devices, check whether a device is alive. I want to see, can you get me some config, and can you set me some config? I mean, we do a few more things, but here's a simple example. Now, not every adapter will be able to satisfy those capabilities, and that's fine, because the ones that can will query those to get the information. But what this does is, we've now separated the how from the what, and we've kind of presented the what at this layer, so that our consumers, the applications that are calling it, and this can be configuration manager, It can be an API. So remember the API first? We have APIs at every single one of these layers. So if you want to go straight to the device broker, there's an API for that. So we're basically just making it easy and just showing what's possible from a device perspective. And this is just from the device broker perspective. Obviously, within our platform, we have other brokers that allow you to create that layer of abstractions across services, policies, and various other things. The net result here is, within Configuration Manager, the Configuration Manager doesn't care how you get the information from the devices, you just see devices. And that's a really powerful story. And I'll show you an example of how we can get these systems to come online and what's happening behind the scenes.
So you're basically abstracting the intent here from the config that you need to push down to devices, so that if you've got a multi-vendor network and you say you're in the middle of a life cycle of devices out in the field and you want to go from Cisco to Juniper or something else, exactly. You can help manage that by separating the intent from the config and the policy and be able to apply the same end goal of I want to push this VLAN or I want this subnet or this policy or whatever that is, using that layer of abstraction. That's
exactly
the problem you guys are solving.
Yeah, totally. I mean, because what's happening in the field today, the ecosystem at the bottom is changing. It's constantly changing. So how do you build a platform that can help people leverage those changes to their benefits? Years ago you had OSS platforms where you just couldn't make any changes because it was too expensive. Right, the integration tax of that layer was just so expensive that people wouldn't make the changes in the lower layers. By being able to, leverage the orchestrators and the controllers, which are now coming to the forefront in the APIs that they present, really helps us. But to Chris's point earlier, there's so little investment in that management plane to actually join these things together in a cohesive way that allows you to scale and allows you to grow, allows you to, migrate over time to really get the benefits from those changes that you're making to your networks.
So are you guys getting early access to code so you can have this built in and ready as new features are released on these platforms?
We are partnered with a number of companies, and where possible we do try and get access to the APIs. I'll talk about how we integrate with those systems in a minute. And maybe that'll help answer how we can actually accelerate that whole layer as well. Yeah. Okay, so before I go into the demo, I just want to touch back on Automation Gateway, because I think for us, Automation Gateway is really how we can get our customers to adopt or even begin the journey of an automated solution. So typically, when people come in with a new platform, a new solution, it's always, hey, look, we've got this great idea. Throw away what you've got and use this, and it's going to solve your problems. We've talked to customers, and we know that's not the case, because they've already invested heavily in the scripts or the DevOps tools and things that they have today that's working for them, right? I mean, if you go back to that line graph that Chris had about where we are today with the CLI world and where we're coming in, we want to be able to, create that merging point. We want to be able to create that point of intersection where you can really leverage what you have and move forward. So the Automation Gateway, allows you to use the scripts and the current tools that you have, and we discover those capabilities, and we generate the models and we generate the APIs for them to be consumed into systems like the Itential Automation Platform, for them to be used as part of this automation journey. And I'm going to show you in this demonstration now how this happens. So if I switch back and actually show you the platform. Okay, so this is the Automation Gateway. Right, so when we log in, on the left-hand side, we're presented with some lists. It's pretty straightforward. We have the list of devices that is currently managed by the Automation Gateway. So this is installed on an environment which has the various scripts and modules or DevOps tools that you want to consume. And we start off by saying, well, these are the devices that are managed by this environment. We can then look at the the modules that we have, and this is installed on an environment which has the Ansible networking modules. So we discover those modules and we present them in this user interface, and I'll show you in a second why we do that. We also consume playbooks. We consume roles, because we know there's a lot of roles that are out there, and we consume scripts. So we discover all this information, we pull it into this environment, and we then allow you to essentially augment or decorate this information. So let me show you an example. So if I look at
Now, real quick though, in that list of stuff that you have there, excuse me, is that a list of all of the modules, pardon me, that you support, or all of the ones that you've discovered on this network that you have set up?
all of the ones that we have discovered in this environment that we set up. So yes, on here, I mean, we literally installed Ansible, and it comes with all the networking modules. So it's just pull it all in, and it's available for you to call. And the real beauty there is, so if I show you, so these are all the iOS ones. So the ones in red are ones that we've decorated. So we've basically augmented the default payload that you need to supply to these modules to actually make them useful. I mean, I'm sure you guys have all played with Ansible. So all the modules have a lot of inputs. Not all the inputs are as well documented as they should be, and you can tear your hair out going, "Now, what the hell do I put into this thing?" Right? I mean, so what we're trying to do is, again, it's all about making life easy for people who want to embrace the automation journey. So we want to make it easy to understand what this module is doing. Right? So we have a list of inputs in this iOS config thing, and that's it's as long as your arm. But what we can do is we can allow you to add better descriptions. We can allow you to add default values. We can allow you to just really narrow down what you want your users to be able to do within that module. And this works really well for Ansible because it's got a lot of predefined inputs. But it'll also work for your scripts, right? Because when Scott writes a script and he's got he's got a fancy, very clever Python script, only he knows how it works, right? If you want other people to use it, you want to provide a little bit more information. You want to provide some checks and balances to make sure that it's not going to, it's going to run in the right way. So this tool is all about allowing you to use those current capabilities. So we discover these things, we generate a model, and we generate an API. So everything that we have here now, we can actually invoke via an API. So if we look at the API documentation that's available within the product, you have the ability to present this to your clients or to the clients of the system what they can do. So if I look at that iOS config module, so we can do a get operation on that specific module, and we can see what the clients would get. If I can type iOS correctly, that helps. Okay, so I do an iOS config, I execute it, I get a 200. And the response body is essentially our normalized data model, which describes the augmented version of this module that you've presented to your consumers, which is a really powerful thing. So now you can actually take all your scripts that are sitting around, and you can find a way of organizing them and presenting them in a useful way. And the reason we did this is, if you look back to the architecture and then we pivot back into our Itential Automation Platform, we want to be able to consume those current capabilities and allow you to build an automation solution that leverages those current capabilities, and also take it a step forward and integrate it to the new controllers and the new management systems that you have in your environment. So the screen you're seeing here is the landing page of the Itential Automation Platform. Let me just make sure I had timed out, so I thought let me just check it's not timed out. So when you log in, you're presented with this screen. All the tiles that you see there, these are the different applications or the different modules that make up the applications and the design studio that we have. And what you're seeing here are things that you're only allowed to see. So, one of the things that we introduced with being able to give you capabilities to everything is, access control becomes critical, and security is important. So at every layer within our stack, right down to the API calls, we have fine-grained access control. So right now, I'm only showing you what I'm allowed to see. The APIs that have been auto-generated from your Python scripts, again, you can control who can access what from those scripts. So that's an important thing to note because we get that asked a lot. Okay, so let's try and go back a few minutes and just, if we go back to the slide that I had there where our configuration manager was essentially allowing us to manage the devices that we discovered through our brokers, through our adapters. I want to show you just an example of how that works. So right now, I've got a list of devices, and the things on the left-hand side, we can group devices together, we can perform backups. Golden configurations are part of the applications, and Alex is going to go through a demo of that a little bit later. But for now, if I just try and show you what we mean by federations and brokerage, we have a means of really discovering the capabilities of these systems in real time. So right now I have one adapter that I have in the system that I've turned on, and that's the Viptela one. So all I can see are the devices that Viptela is telling me that it manages. But in the slide there, I showed you we have Ansible and we also have NSO. So if I turn those on, I can go into my system page, and the system page is, it's all about the health of the system. So I can see some basic information. I can see the applications that I have installed on here. I can also see the adapters. And the reason obviously I've intentionally turned these things off because, I want to drive home the power of this federation and the abstraction. I can see we've got two of the adapters are disabled, and the Viptela one is on. So, the broker is going to the systems that say I can do this stuff, and it's pulled out the devices. So if I turn on the Ansible and the NSO one, let me turn it on rather than drill into it. Okay, so if I turn these on, then what's going to happen is the adapters are going to come online. They've registered with the brokers saying, hey, I can satisfy this capability. I can give you the intent that you're after. I can give you device information. I can give you, the ability to set configuration and to view configuration. And having done this, and also remember the adapters can satisfy different brokers. So if it's a service orchestration platform, I can give you some information about services, which becomes important when you start looking at service-related applications and being able to create the abstraction layers in that domain. But having turned these things on, if I now go back into my configuration manager screen, and when I click on devices now, so in real time, this is making a call to the API. So this is happening right now. It's not cached when I turn it on. I've clicked on the devices screen. It's called an API. The API has gone down to my broker layer and said, hey, I need to see a list of devices. The brokers have said, right, which adapters are up to see the devices? It's gone down to the device and said, give me the list of devices that you guys support. This has basically got the different set of data from the different systems across different models. It's combined those into a normalized view. It's sorted it, it's paginated it, and it's presented it back up to the client, which in this case is the configuration manager. So that's all happened as I just literally click that button. Now this means, we are using abstraction to make sure that we can always get the different sets of devices from the different systems as they're introduced. But we're also using federation because this is real-time information. If the Viptela controller suddenly says, hey, this branch is offline, it's going to show me it's offline on here. So we're getting real-time information, which is crucial in today's day and age when you need that information to make decisions and really trust the data that you're working with.
So I've got a question for you on that. In looking at the adapters that you have as you're trying to interact with these devices, so specifically you've got a Viptela adapter, which I know has got a level of netconf support. So where's the dividing line in that? Do you find that certain vendors, you've got to build a specific adapter because there's things that you want to do that you can't do in netconf, or why wouldn't you put it all in netconf?
It depends on what's easiest to integrate with.
Okay.
And it depends on you could have both. So there's no reason why you couldn't have a Viptela netconf adapter and a Viptela HTTP adapter.
Okay.
It just depends on what you're trying to get from that system. Because I know in some cases, certain operations haven't been exposed through netconf.
Got it. Okay.
And in some cases,
If there's something you're after in the GUI that you can't get through netconf for whatever reason, you've got the ability to grab it from both ends so that you've got full control of the device.
Yeah, I mean, so it's all about separating from the end user's perspective. It's separating the details of how. So if you can separate the details of like, well, if the client wants capability X, and if you know that's only available through netconf, then creating the layers of abstraction to be able to separate that.
Right. You don't care how anymore. If you can get to it, you don't care how. It's just there.
Exactly.
Okay.
Exactly, and that provides a really powerful story.
How fast are you able to do the vendor-specific adapters? Because there's so many network vendors out there. If somebody comes to you and says, "Hey, I want my vendor in there. You guys don't have it." What's the time? How long does that take to build?
Good question. Give me
Later slide. Okay.
Give me literally 30 seconds, and I'll talk about that.
Okay. Cool.
So I mean what we've done here is we've kind of using the adapters where we're using the notion of separation of concern, abstraction, federation, and you get the idea that we can get some real-time information. And I just want to check we've got so we've got everything online here. So much so that we can drill into any one of these devices, load the configuration, and it's just it's fetching this information real time, and that's a critical point that we need to ensure people get, because modern networks change so quickly, and without real time information you can't automate, you can't trust the data is valid. So coming back to your question about different adapters, different vendors, you're right. I mean there are so many systems out there. There are so many different ways of doing the same thing. Let me switch back to my slides. Let me just close these, and if I switch back to the next slide. Okay, so adapters. So the adapters are, you've obviously guessed, the important part of how you do the things. The brokers give you the separation of concern and allow us to define an intent-based system, which kind of declarative from the model perspective, but it separates the how from the what. So adapters for us are really a means to an end. Right, so if you're going to automate a solution that requires integration across multiple systems, you have to be able to talk to those systems. Right, that's a given. If you can't, then you won't be able to build those solutions. Now, a lot of systems have APIs, and we recognize that in the past, customers have been put away from going down this route because of the integration tax. People spend a lot of money just writing those integrations. So we want to bring the integration tax down to zero. What you see up on the screen here is it's just a list of vendors and a list of systems that we have come across in the past, and this is a subset of adapters that we currently have today that you can download from our public website and leverage in our system. Adapters for us are a commodity. It's a means to an end. Right? You have to be able to talk to the system to be able to use it. So we are trying to make it easy. We are literally trying to get the barrier of entry to this thing to zero, because without the adapters, our platform is, you have to spend so much time writing these things, then what's the point? It's always going to be an uphill struggle, right? So we've built a library of adapters of the common systems that we talk to, and this is just a subset. There's a lot more on the public website, and they're all available in our open source GitLab repository or an npm download. And then if you go on there and you say, hey, look, I use this system, and you don't have it on there, how easy is it for you to put it into your So we've gone a step further. So we've actually developed a tool that's on the public domain, on the same developer site, which Chris will talk to you about in a minute, where you can point to the Swagger documentation or the Open API documentation, and we'll read the documentation, and we will generate the code that will talk to that system. So we've got code that generates code. And you literally step through the wizard. You give it. We also support Postman Collections. So if your system doesn't have a well-defined Swagger document, then just point to a Postman collection that you as a developer to validate these calls work. Put it into our wizard. Step through the various steps. You give it information because the adapters do. They do some powerful things. You can throttle the calls. You can add security layers. So they do a lot more than just talking to the system. They do it in a intelligent way. Step through the wizard, it'll spit out a zip file. You drop the zip file into the platform, And before you know it, in that list of the traffic light list I had up there, it'll appear on there. And in a minute, Alex is going to show you, why that's important and what you can do with it. Because once it's in our platform, you have the power of that system in your hands, leveraging the automation studio and the tools that we have. You can then build solutions very quickly, very easily. And this all comes back down to why are we doing what we're doing? Low code. We want people to be able to do. We don't want people to have to code their way around this. Everybody can click through a wizard. Everybody can copy a file from A to B. And then once you have it there, you'll see in a minute how easy it is to use our tools to then start consuming some of these capabilities. And that's how you start building these solutions. And that's how we see the rate of adoption of automation growing.
You might have just covered this already, but I've been tweeting. You have a solution for equipment that doesn't have an API? That's still traditional CLI or other methods?
Yeah, so the automation catalog that you saw earlier, that's one solution, because the automation catalog allows you to point to existing DevOps tools or scripts. They can also point to it's very easy to build a new adapter that doesn't talk to a well-defined API, but you can use the automation gateway to do that for you as well. It's just a way of how do you take the current means of communicating with that system and creating a model that allows you to consume it in a well-formed manner.
And how do you secure a system like that? When you're accessing older systems, usernames and passwords and all that, is there a database, or do you tie into Radius or TACACS?
So we have support for most AAA systems. So we have within our platform we have support for like LDAP and Radius, and we also so a lot of these systems are talking to the controllers where they have the information to manage those systems.
Right, I was specifically
for the ones
talking
for
about
the CLI
older ones, the CLI.
So they would be held in our automation gateway. So within there, we would have a security layer that allows you to store sensitive information.
Okay, thank you.
You guys basically built your own vaulting service, or using a commercial vault, or using something like HashiCorp Vault, or what are you guys actually using for identity store? And
so on the DevOps thing, so when we had Ansible Manager, we would leverage what Ansible supports. So HashiCorp Vault would be one option. It really depends on what your systems have support for. It really depends on what you have in your environment.
Sure, and I can add to that because we're about to get in the next section. So the central platform hooks up to your choice of LDAP, AD, Radius, and we are not going to allow you to take any of those route calls without that authentication. That calls to that local box, and you can have a second layer local if you choose within that DevOps platform to implement. They're both called Vault, so whether it's Hashi or Ansible's. But
and you're doing the same thing for like service principal roles in AWS. So if you're doing AWS with service principal role, you have a first set of role-based permissions that allows you this. Are you allowed to actually make that call, and then you actually go against the service principal and say like you can apply it?
That's right. Perfect world is you have a single auth token that we can pass around for all these things. We are going to protect any API call within our system. We're going to pass authentication parameters or token parameters to the subtending system and expect those systems to have the same level of permissions. So we are the gateway to anything you allow to access through us. But you have to remember, one of the core principles is that we're sitting on top of other platforms, and we are not the gatekeeper for everything, because just like Anand said a bunch of times, when we're sitting on top of a robust system, you can still log into those systems and make changes. We just look like a power user of that system. So we are going to control and provide all the robust RBAC down to the route on our system. We're going to pass either machine parameters or the person who initiated that as a token down to that subtending system, and that system can protect itself through whatever means it chooses to.
So most people, when they're deploying your solution offering, they assume that you assume they're going to build a service principal role on top of whatever that deployment's going to be, right? So if it's going to be like, hey, I'm going to use Ansible, I'm going to have one set of key sets that I'm going to manage for Ansible to be able to interface that way, and then it's going to deal with the surface principal role based off of what's being asked.
Yeah, I wish it was usually that simple, but usually there's a variety of mechanisms because we're sitting in a multi-domain environment. So typically you're going to have this team uses this tool and this is how they've chosen to do it. This other team manages these sets of tools and there's a different paradigm.
Right.
So we're going to have a single enterprise-wide LDAP communication to apply any request to us. And then we're going to try to respect the people we're talking to in the sense that they have a system, people are going to log on and make changes. You're allowed to pull the rug out from under us. We make no expectation of caching data. We're a real-time user of that system, just like a human would be logging in. So we have localized security parameters, and then we will guard ourselves. And we will use the authentication mechanism of those subtending systems to respect the way they want to be integrated with.
Okay. And then do you guys actually support on the identity and access side? You guys will integrate with like, an Okta or Duo for two-factor configuration?
There's a variety of SSO. I mean, if we want to start talking about OAuth mechanisms and the variety of variation that exists. But yes, we typically are going to pull groups and authentication parameters from a third party. If we separate authentication from the authorization component. But yes, we can accept just a token if you would like to.
Okay.
Typically, we have to integrate with a group-based system to pull in those group-based roles because not many people want to re-implement that all in a third-party platform. So we're going to pull in those groups, map them to your capabilities, authenticate, and then allow you to do what you're going to do. Back down to the script execution, if that's your choice, with an automation gateway through that route that was provided in the documentation.
Okay.
Now, in that, I can see a whole lot of things becoming separated really fast if you have some people logging into this, some people logging into that, and not necessarily coordinating.
That's right.
Either do you or have you thought of serving as a proxy for their authentication to technically go through you to do that, so at least you have the awareness up front that, oh, by the way, this is about to occur?
So since we have, I think, a pretty robust set of capabilities, we get asked to bend a lot, I would say. I think we're pretty adamant in the sense that we're going to be responsible for the things you ask us to do versus being a global authentication routing mechanism or some sort of API bus mechanism, which I think there's a lot of robust capabilities out there. But we do, what we don't want to do is just because Itential's involved, all of a sudden, we're the lockdown mechanism for all these systems, because the whole idea of adopting these modern principles is that the old way of doing architectures, we had EMSs and then NMSs and had to go through the NMS to talk to the EMS, and you can't change it here because I took a copy of that. That rigidity is what kind of caused us to not have a very good management automation ecosystem. So when you see us in an ecosystem and you have those subtending systems, they just see us as probably the most robust user they had ever seen, because we maintain netconf connections and we're pushing through volumes of network changes, but we fully expect people to continue to use those systems. If I tell somebody, we're now going to automate some Meraki stuff, you're not allowed to log in the Meraki controller and make any changes. That's where the world came from. We don't want to behave that way. We just want to, if you choose through our automation platform to inflict a change on that, it'll look just like an API call to them, just like anything else.
All right, so then I guess in that sense, what do you do to prevent becoming, disconnect is really not the word from a technical point of view, but from maintaining awareness to what other things are going on, so you don't go all of a sudden somebody logging in on your side wanting to make a change, and you're like, oh yeah, we can do that, wait, what the hell just happened over there? And losing sight of something else going on because, like you said, you're not in front, you're not locking it down.
That's right.
At the same time, how do you prevent losing touch with?
Because any action we take in the system, we're going to make a real-time API call to what it is now. I'm not going to presume that I thought something 5 minutes ago and that it still exists. And of course, there's race conditions, and we can get into that. And I think when we get into the infrastructure as code, how do we manage massive change in the environment? Yeah. How do we coordinate it, test and validate that in a meaningful way? I think that's the best place to maybe address that, if we could.